Okay, so for continuing where we left off, after we finish this question, we get m equals 10 to the 1 over 3.5 power, which times a relative mass of the sun. So this could also equal this is the same thing as the 3.5 root of 10, and then that times the relative mass of the sun. Alright, next up, they describe Cepheid variables. They say that there are occasions where Cepheid variables are close enough to Earth, and we can approximate their distance by using the same equation. Apparent brightness is equal to luminosity over 4 pi distance squared. And if luminosity and period were plotted, this is the graph. Now, so it's a logarithmic graph. So the values scale up. So like from here on the x-axis, from here to here, it goes 1, and then from this line this is 2, and then from this line this is 3, and however from 10 it goes by 10. So this would be 10, this would be 20, this is 30, this is 40, 50, 60, and then up to 100, and after 100 it will go by hundreds until 1,000. Alright, so, and then this is useful because this helps us see luminosity for what period or what day the Cepheid cycle is on, the Cepheid variable is on. So how we solve it is for question 17. A Cepheid cycle has a period 20 days and a brightness of 8 times 10 to the negative 10 watts per meter. Calculate the distance from the Earth. So we can use, we know that it's 20 days, so if we look at the graph, it's this is 10, and then this would be 20, and 20 is right around here. So that's 1, 2, 3, 4. That's like 6 times 10 to the third. 6 times 10 to the third. So when we go here, we just use the formula again, but we're solving for distance, so the formula is rearranged for distance. So distance is equal to the square root of luminosity over 4 pi times b, which is apparent brightness. So in this case, we have two values for luminosity, and we multiply both. Because the star is 6 times 10 to the third greater than the luminosity of the sun, and the luminosity of the sun is 3.84 times 10 to the 26, and this would be all over 4 pi, and they give us brightness, so we can use that as the b value. So 8 times 10 to the negative 10, and this is all being square rooted. And once you calculate all this, and once you calculate all this, you should get distance is equal to 1.5 times 10 to the 19 meters. Alright. Now for our final problem, we're going to be doing question 3 from the practice questions. Alright, question 3. So, I'm only going to be drawing out the ones that require calculations, because the other ones are explaining, and I'll explain them. So, question 3, the first part is define these two terms. Luminosity is the power radiated from a star, and that's the definition. And apparent brightness is the power from a star perceived by a person on Earth. So that's why it's the apparent brightness. And moving on, B, state the mechanism for the variation in luminosity of the Cepheid variable. So the mechanism for variation is the size of the star being observed. Because the star changes in size, surface area increases, therefore more energy, thus more luminosity changes as the Cepheid variable increases. And then they show this graph. They have 2 points in the cycle, A here and B here. C, part 1, assuming the surface temperature of the star stays constant, deduce whether the star has a larger radius after 2 days or after 6 days. So this is a conceptual thing. The brighter it is means that it has a larger radius perceived. Well, not perceived, not just perceived, but like because it grows as well. So because point A, which is around 2 days, after 2 days, it's brighter than the mark after 6 days. After 2 days would be would have a larger radius. And then C, part 2, explain the importance of Cepheid variables for estimating distances to galaxies. So period of Cepheid is related to the luminosity, and then because the period calculated gives us luminosity. And the brighter it is, apparent brightness gives us the distance from Earth, and then once we have those two, we can solve the distance from Earth, and then that means we can deduce the distance from Earth to where the star is, and then thus where the star takes place in the galaxy, and whatever galaxy the star is. Moving on to part D, this one actually has calculations, so I'm going to start writing. The maximum luminosity of this Cepheid variable is 7.2 times 10 to the 29th watts. Use data from the figure to determine the distance of the Cepheid variable. So, looking at my notes. So, because it says maximum luminosity, and we are only marked these 2 points, or the 2 points don't really matter, just it's maximum luminosity, therefore when it's the most bright, and it's the most bright at around 1.25 times 10 to the negative 10 watts per square meter. So that's what we're going to use for our apparent brightness in the equation. So we use the same equation, just rearrange for distance. So d distance is equal to the square root of luminosity over 4 pi times apparent brightness. In this case, brightness would be the value we get from the table, the highest value we get from the table right here, and it's 1.25 times 10 to the negative 10 watts per square meter. So luminosity they give us is 7.2 times 10 to the 29 watts over 4 pi times brightness, which is 1.25 times 10 to the negative 10. And then this we can calculate for distance. And after that we get 2.14 times 10 to the 19 meters. This is the answer for D, part D of question 3, the first part of part D. Moving on, I think that's the only calculation, and then this is another conceptual problem, so I'll explain. Cepheids are sometimes referred to as standard candles. Explain what is meant by this. So a standard candle is an object where luminosity is known. So the question, standard candle is an object where luminosity is known, and this is shown by this definition. If you know the luminosity of the candle, you can measure its distance. The further away it becomes, the dimmer it becomes. And then, because the Cepheid variables change in luminosity, they function in the same way. So standard candles, we know the luminosity, and distance can be calculated by measuring the brightness. And then, thus, luminosities of the Cepheid variables are known. Thus, they can be called standard candles. And that's basically it. So so this question was worth a total of 13 marks. And you can see a majority of it comes from the conceptual parts of astronomy. So it's important to read up on what astronomy is, not just what the formulas are, because formulas were only worth, in this question, were only worth 3 out of the 13, and the rest were more of a conceptual understanding of it.